You have walked past a crow 100 times without thinking about it. On the fence while you take out the trash. On the telephone wire above the parking lot. On the oak branch at the edge of the park where you walk every morning. You glanced up, maybe. You moved on. You thought nothing of it. The crow thought something of it. That specific crow, on that specific fence, has been watching you. Not birds in general. Not people in general. You. It knows your face. It has filed it. And depending on what has passed between your species and its family in this neighborhood, it may have already told its children about you. Children that have never once seen you themselves, but who would recognize you instantly if you walked beneath their tree right now. This is not folklore. This is not the kind of thing people say about crows, because crows seem mysterious, and it makes a good story. This is the documented result of field research conducted by John Marsluff and his colleagues at the University of Washington, who set out to test whether American crows could identify individual human beings and transmit that information across their social networks. The answer was yes, with a precision that surprised the researchers themselves. If you want more videos like this one, subscribe before you leave. There are many more coming, and what you are about to learn will permanently change the way you look at every crow you pass for the rest of your life. The common version of this story goes something like this. Crows are smart. Crows hold grudges. Don't mess with crows. That version is emotionally accurate and scientifically incomplete. The interesting question is not whether crows remember. Many animals remember. The interesting question is how a bird with a brain the size of a walnut recognizes individual human faces in field conditions, retains that recognition across years without reinforcement, and then transfers that specific personal information to unrelated flock members and to offspring that were not present at the original encounter. That last part is the part most people miss entirely, and it is the part that changes everything. The experimental design is worth understanding, because the design is what gives the findings their weight. Marsluff's team did not simply notice that crows seemed to dislike certain people. They built a protocol specifically designed to isolate facial recognition from every other possible variable. Researchers wore a rubber caveman mask while trapping and banding wild crows on the University of Washington campus. The trapping procedure causes mild short-term stress, but no lasting harm. When moving through the same routes without trapping anyone, the researchers wore a different neutral mask. The masks controlled for clothing, gait, height, and route. The only variable that differed between the two conditions was the face. The dangerous mask, the one associated with trapping, triggered immediate scolding, diving, and mobbing every time it reappeared on campus. The neutral mask did not. The scolding response persisted across time in exactly the opposite pattern from what you would expect if the birds were simply reacting to a recent unpleasant stimulus and then forgetting. It did not fade. It grew. Then the team did something unusual. They kept wearing the masks for years. A crow that had been trapped during the original experiment continued scolding the dangerous mask years later with no subsequent reinforcement of any kind. That alone places corvid associative memory in a category occupied by very few non-primate species. But that is still just individual memory. The more significant finding came from what happened to the population over time. The proportion of crows on campus scolding the dangerous mask did not decrease as the originally trapped birds aged and disappeared from the population. It increased. Young birds that had never been trapped, Birds that in some cases had not yet hatched when the original trapping occurred were now scolding the mask. The information had moved, not through genetics, through social transmission. When a crow mobs a perceived threat, other crows within earshot pay attention. They observe who is being targeted, where the threat is located, and which individual is giving the alarm. Crows with no prior negative experience of their own update their threat assessment based on the alarm calls and behavior of birds they trust. The speed and reliability of this process in corvid populations is extraordinary. The second transmission pathway runs from parents to offspring. Young crows remain with their parents for an extended period after fledging, significantly longer than most songbirds, accompanying adults on foraging routes through their home territory. During this period, they are, in effect, being trained. When a parent scolds a specific human face, the fledgling registers that face as a known threat category. The parent does not explain why. The mobbing behavior itself is the lesson. The fledgling leaves the nest already carrying a list of people its parents consider dangerous. That list is accurate. It is specific, and it will be passed to the next generation in turn. The most compelling evidence that crows are processing specifically facial information rather than responding to something less precise like clothing color or movement pattern came from a follow-up study in which researchers scanned crow brains while showing them images of the dangerous and neutral masks. The brain regions that activated in response to the dangerous face were associated with threat detection and emotional memory, the same neural circuitry that performs those functions in mammals. The neutral mask activated regions associated with novelty and attention, but not the threat signaling network. The crows were not simply behaving differently toward two faces. They were perceiving them differently at the level of neural activation. The dangerous face was being processed as a threat, the way a face is processed by a mammal that has learned to fear it. This finding sits within a growing body of work suggesting that corvid cognitive abilities have evolved to a level long considered dependent on the neocortex in mammals. A 2024 study showed that crows can count vocalizations up to 4, producing a specific number of calls on command, a capacity previously documented only in humans and certain primates. Researchers have also shown that crows can recognize geometric regularity, identifying an anomalous shape within a set of otherwise uniform polygons. The neural substrate underlying these abilities, the caudolateral nidipallium, a functional analog to the mammalian prefrontal cortex, has become a central focus in comparative neuroscience precisely because birds evolved sophisticated cognition along an entirely separate evolutionary path from mammals. Two lineages, two completely different routes through 400 million years of vertebrate evolution, the same destination. The word grudge appears everywhere in popular coverage of this research, and it deserves careful handling. A grudge in the human sense implies rumination, an ongoing internal narrative directed at a specific individual across varying contexts. There is no evidence that crows ruminate. What they appear to maintain is a long-term threat classification tied to a specific human face, which manifests behaviorally only when that face is present. The crow is not sitting in a tree thinking about you, but the moment you walk beneath that tree, the classification activates instantly, accurately, and with a consistency that has persisted across years and across generations. That distinction matters because it changes what the finding actually demonstrates. Crows do not hold grudges in the way humans hold grudges. They maintain discrimination, a stable assignment of a specific face to a specific category, across years and across the boundary between individual and social memory. The behavior toward the face is consistent enough that it looks like resentment from the outside. The cognitive content is closer to a persistent identification that fires when the relevant signal appears. The paradox, and researchers who covered the original Marsluff work used that word deliberately, is not that crows have a rich inner life. The paradox is that an animal we have lived alongside throughout the entire history of urban human civilization has been quietly maintaining detailed records on individual people this entire time, and almost no one noticed until someone put on a mask and started counting. Think about what that means for the neighborhood you live in right now. If crows can identify individuals, retain that identification across years, and distribute it socially, then the crow population around any human settlement carries a continuously updated map of which people are safe, which are irrelevant, and which are dangerous. That map is not stored in one bird. It is distributed across the flock and updated with each generation. A grievance against a specific person is, in effect, an entry in the flock's institutional memory. This is a fundamentally different model of urban wildlife than most people carry. The standard model treats animals as essentially anonymous, interchangeable individuals responding to stimuli. The Corvid data suggests that model is asymmetric in a way that should feel unsettling and remarkable in equal measure. The birds know who we are. We do not know who they are. Other corvids, ravens, magpies, jackdaws, show comparable individual recognition abilities. There is preliminary research suggesting that certain parrots and some shorebirds may possess similar capacities, but crows are the species most thoroughly documented, and crows are the species most thoroughly embedded in human-populated landscapes across North America, Europe, and Asia. The animal most likely to be watching you from a wire right now is the animal for which the evidence is strongest. The dangerous mask is still worn occasionally on the University of Washington campus. More than 15 years after the original trapping, the scolding has not stopped. None of the crows currently responding to that mask were alive when the first trapping occurred. They learned it from their parents, who learned it from theirs, in an unbroken chain of avian social transmission that has now outlasted at least 3 complete crow generations and shows no sign of fading. The crow on your fence while you take out the trash is not a generic crow. It is a specific individual with a specific history of observations that includes you. If you have given it no reason for concern, that history is probably neutral or even positive. Crows are also documented to show preference for people who feed them regularly, occasionally bringing small objects in what researchers interpret as reciprocal exchange behavior. If you have given it reason for concern, that history is stored, and it will be passed forward. You have been living beside this for years without knowing it was happening. The bird on the wire is not watching the street. It is watching you specifically, updating a record that began before you noticed it, that will continue after you go inside, and that your neighbor's crow already knows about. Now you know. Tell me in the comments, have you ever felt like a crow in your neighborhood was specifically watching you, or following you, or responding to you differently than to other people nearby? I want to hear about it. I read every single one. I'll see you in the next one.